And welcome back. This will be a set of weekly videos, and what I'll look to do each time is just go through the hardest 5 questions from each GCSE paper. So this will build slowly over the next few months. Now, as with all questions, I can't say these are going to be the hardest. Different people find different things harder, but case in point, I've missed one of the later questions out in order to ensure I get a vectors question in, because I know people don't like vectors, and vectors is a good thing to practice, because once you've done quite a few of them, they will mean a bit more to you. So let's look at this first question. So the first question, so I'm going to read through, I'm going to do all these not too quickly, but I'm going to sort of shoot through all of them, but I will try and explain as I go, which is obviously the point of the video. So this first one, so OXYZ is a parallelogram. That's important because that means that I know that this is equal to this, and I know that this is equal to this in vector terms, and that gives me a lot of information straight away. The other thing to note is with a vectors question, it is worth having to read all the way through before ploughing in, because often that will help you decide which way to go or how to think about the question. So what do I have? So it tells me that O to Y is A, and actually straight away that's quite unusual because it's giving me the diagonal, it's not giving me one of the sides. Then it also says a bit further on that the break between O to Y is 1 to 3. So in other words, this is 1/4. 1 to 3 is 4 parts. So 1 part here and 3 parts here, which means, and I'm going to write it here because I don't want to be moving up and down too much, which means I can say that O to M must be the same as 1/4 A, and M to Y is the same as 3/4 of A. And that may or may not be something I use later on in the question. Similarly, it tells me the point N is on O to Z, such that O to N, N to Z is 1 to 2. So this is 1/3 and this is 2/3. Again, the idea 1 plus 2 is 2 parts. O to N is 1 part and N to Z is 2 parts. So I can also write that O to N is equal to 1/3 of B, and N to Z is going to be 2/3 of B. Now, the important thing with these questions, and this will apply throughout all these questions, is you need to clearly lay out what you're doing. So obviously I'm squishing it in a little bit so you can see the whole question in one go, but at the same time, try and keep it in order. Then what does it want me to do? So it wants me to work out the ratio of X to N, M to N, and notably it says you must show all working. So that means if I guess at a number, so let's say I guess at the number 5, I don't know what the answer is, by the way. If I guess at the number 5, well, that means then I will get no marks unless I explain where that 5 comes from. Now, this is one of those questions where it kind of tells you what to do in the question, because it says it wants the ratio X to N, M to M. So I'm clearly going to have to work out X to N, and I'm clearly also somewhere going to have to work out M to N, and then compare them and talk about the ratio between the two. So let's start with what is probably the easier one, which is M to N. So M to N. Now, I always also, with vectors questions, try and make sure the arrows are on, because that ensures I always go the right way down the diagram. So I know, and you can see I put a B up here, that's 1/3 B, and that's 2/3 B, and that is 1/4 A, and that is 3/4 A. So I've now got all the arrows and all the directions on. Anyway, so M to M, not too bad, because M to M is going to be M to O, and then I'm going to add on O to N. M to O goes against the arrow, so it's minus 1/4 A, and then I'm going to add on 1/3 of B. Now that's messy. And remember, this is a non-calculator paper. That's messy. We're going to leave it like that for now and see if I can tidy that up later, depending on what X to N looks like. Now, X to N is an interesting one, because X to N, I'm going to do it and highlight it down here. I'm going to go down here, I'm going to go across here. But I can't do that because I don't know what O to X is. So I'm going to have to work that out first. So I'm going to work out O to X. I'm going to do it in a different colour, which just means it's slightly easier to follow what I'm doing. So I'm going to do this down here. So therefore, O to X, which I'm going to need, is, well, I'm going to go from O to Y, and then I'm going to go from Y to X. So again, I'm writing what I'm doing. So O to Y, and then I'm going to go from Y to X. And then using my diagram, I can see that O to Y is clearly A, so I'm going up the diagonal. And I can see that Y to X, well, I'm going the opposite way of B, so therefore it's going to be minus B. So I'm actually just going to change this plus to a minus, just to keep it clearer what's going on. So that's a minus B. So therefore, going back to X to N, I can say X to N is going to be X to O, which is the opposite of what I've just done, plus O to N. And X to O is the negative of what I've just done, so it's B minus A. And then I'm adding on O to N, which is 1/3 of B. And let's tidy this up. So that's going to give me, well, B plus 1/3 is 4/3. So that's 4/3 of B minus A. Now, look at what I've got. Look at these two things here. They don't look the same at all, do they? I'm going to have to do some work to try and make them somewhere comparable. So what I'm going to do is I'm going to leave the x to n as it is, because I think that's kind of okay. I'm happy with that one. What I'm going to do with the b, I'm going to do a step in between so you can see what I'm doing, is I'm going to convert these to twelfths, and you'll see why I say that in a second. So this first one is the same as 3/12 a, and then the second one is the same as 4/12 of b, because 4/12 is a third and 3/12 is a quarter. Then I can take a 12th to the outside. So I'm going to factorise a 12th to the outside. I'm going to put them back to front so they're in the same order. So that's going to give me 4b minus 3a. And on this one here, let's get rid of this yellow box, can get slightly confusing. So then for this one up here, what I'm going to do is I'm going to factorise out a third. So that's going to be a third, which leaves me with 4b. Now if I take out a third, I need a to be 3 times larger, minus 3a. And suddenly these don't look too bad, do they? And moreover, I can see, well, hopefully you can see as well, that m to n is a quarter of, or in other words, x to n is the same as 4 lots of m to n. And there's the answer to my question, because remember what I'm trying to do? I'm trying to work out the ratio of x to n. I know x to n is 4 times larger, so therefore my ratio of x to n, m to n, is 4:1. Question done. That is quite a difficult question. Again, I probably could have done it quite a lot quicker without all the explanation, but equally, I couldn't have missed any of those bits out. I still had to do all those bits. Next question. All right, so this next question is not too bad. This next question looks like more of a just straightforward, can you rationalise? And there's a bit of playing around with Surds at the one underneath. So let's just go straight for this worst one. So I would notice when I rationalise, there's no plus or minus in the middle. I multiply by the bottom surd. 15 times root 5 is 15 root 5, and root 5 times root 5 is 5. But it says simplest form, so I would also lose a mark if I don't recognise that 15 divides by 5, which is 3, and that gives me 3 root 5. That's not terrible. Next part of the question. Now what's nice about this question is it tells me the form it wants it in, and root 3 is clear. So I can see that's a root 3, but that is not a root 3. So I need to convert the 75 into a root 3. And the way I do that is I remember that root 75 is the same as root 3 times root 25. And root 25 is 5, so that is the same as 5 root 3. Which means I can write my initial statement as 5 root 3 minus 2 divided by 1 plus 2 root 3. Then I can rationalise top and bottom by multiplying by the negative of the thing below. So 1 minus 2 root 3, 1 minus 2 root 3. And then very carefully work this out. So 5 root 3 times 1 is 5 root 3. 5 root 3 minus 2 root, or 5 root 3 times minus 2 root 3, or 5 times minus 2 is minus 10, and root 3 times root 3 is 3. Minus 2 times 1 is minus 2, and minus 2 times minus 2 is plus 4 root 3. And then all of that is divided by, well, this is a difference of 2 squares, so 1 times 1 is 1, 2 times 2 is 4, and root 3 times root 3 is 3. Remember what I'm trying to get to. Always keep this in the back of your head so it looks something like this. Let's now collect. So minus 10 times 3 is minus 30, minus another 2 is minus 32. And then 5 root 3 plus another 4 root 3 is 9 root 3s. And all of this is divided by 1 minus 12, which is 11 negative. And that is sort of my final answer, but it's not, is it? Because the question's got a minus in the middle. So if I divide top and bottom by minus 1, or multiply by minus 1, that gives me 32 minus 9 root 3 all over 11. They're all integers. Question done. Happy with that one. Okay, so this next question is a functions question. Again, it seems to start quite easy, but definitely I would imagine gets a bit harder underneath. So the first part is, well, actually there's only one x in my f of x. So I can do this by the flow diagram method. So I can just say that f of x is the same as multiplied by 5, then I take away 3, and then I divide by 4. So if I do that back to front, that gives me f minus 1 of x. So what do I do? Well, the opposite of dividing by 4 is to multiply by 4. The opposite of taking away 3 is to add 3. And the opposite of multiplying by 5 is to divide by 5. And that's my inverse f of x, or f minus 1 of x. First part, not terrible. Second part. So the second part says for all values of x, this is my domain or my input, which is a word you won't really come across until A level. And what I noticed is g of x, which is just, I might need to know, is a parabola which is shifted across by 1. And h of x is a line with a negative gradient that goes through 1. May or not be relevant, but I haven't wasted much time doing that. And then it says, oh, actually, this isn't too bad at all. Then it says, work out g of h of x. So I'm going to do g of h of 5, which means I'm going to put 5 into the h equation. So 2 times 5. 2 times 5 is 10, 1 minus 10 is minus 9, so I want g of minus 9. Well, what does g do? Well, g takes away 1 and then squares the answer. So minus 9 minus 1 is minus 10. Minus 10 times minus 10 is 100. Question done. Okay, so this question looks much tougher, doesn't it? Because there's quite a lot going on here. So semi-finals, A plays C, C plays D, 2 winners play each other. Wow. Work out the probability. This is the key to the question. The key to the question is, what does it want me to do? So I don't care about C winning or D winning. I want A to win. So let's think about how that's going to happen. So for A to win, A must beat B, and then A must beat C, or A must beat D, depending on which wins out of their match. So I've got two combinations of things that can happen here. A beats B and then A beats C, or A beats B and A beats D. Either way, A must beat B, so I'm going to use this 0.6 here in both cases, so 0.6 and 0.6. So this is kind of like a tree diagram, but not really, because it doesn't really work in that sense. Now, in order for A to beat C, well then C must beat D in the first place. I'm going to use this one here. So C beats D with 0.2, and then A is going to have to beat C with a 0.5. This is quite a clever question. I like this question. Good question, this one. Similarly, for A to beat D in the final, then D must have beaten C originally. Well, if C beats D with 0.2, then D beats C with 0.8. And if you're following along with that, well done, because it's very hard to say out loud. And then I need the probability that A is going to beat D, which is this one here, which is 0.3. And I've got my two probabilities. Right, so remember this is a non-calculator paper. I need to very carefully work these things out, don't I? So 6 times 2 is 12 times 5 is 60. But then I'm dividing by 1, 2, 3 zeros. So that's going to be 0.06. Similarly, 6 times 8 is 48. 48 times 3 is 144. Divide by 3 zeros is going to give me 0.144. Add these together. I'm going to make it slightly easier for myself by putting the extra 0 on here. And that's going to give me 0.204 or 20.4%. That is a good question. Okay, so this next and final question today is a circle question, isn't it? And I'm given a circle, so I would note this is a circle which goes through 0, 0 and has a radius of 2. And then it says, find the equation of the tangent to C at the point P1 where P is greater than 0. So actually I'm going to draw this diagram slightly better. I won't really need to draw a diagram, but it's just so I can explain it better. And there's my tangent there. And then it says, and this is the point here, which is P, and this is 1. Now, this is a pretty standard thing we should do quite a lot in lessons. So the way you do this is, in order to work out the equation of the tangent, I need the gradient of the radius. So the gradient of the radius is 1 up P across, so 1 over P, which means the gradient of the tangent is the negative reciprocal, which is minus P. And then I put all this together using y minus y1 equals mx minus x1. Now, as an aside, some teachers don't teach that to A level. And I don't know why, because actually it's really helpful. But if you use the plus C method, in fact, you'll still get to the same answer. But I prefer this one. So then I'm going to use the point P1. So if I put in my 1, that gives me y minus 1 equals gradient minus P times x minus P. Then expand. So I've got y is equal to minus px minus this plus p squared plus 1 from the other side. Problem is, this doesn't look anything like the thing that I need. So what am I missing? Well, the thing that I'm missing is P1 must lie on the circle, which means if I put P into here and 1 into here, that must give me 4. So I've now got another equation, haven't I? So I can also say that P squared plus 1 squared, just 1, is equal to 4, which means P equals 4 minus 1 square rooted, which is root 3. And now I can see where this square root's coming from. So let's now put this in. So therefore y, remember P is root 3. So P is minus root 3x, that's looking good, plus P squared, or root 3 squared is 3, plus 1. Make it look like the answer, and that's going to give me y plus root 3x is equal to 4. And that is my final answer. And that's all the questions done so far. This is going to be a regular series. Do let me know how they went for you. Any questions, anything you're not sure about, let me know down below, and I'll see you for the next paper. Thanks all.